Hey guys, it's Mr. C coming at you here with your exponents lesson today. So let's go ahead and get started. So we can show exponents, and it's really showing repeated multiplication over and over again. So I want to talk about some of the parts of the exponent so that way you know what's going on here. So the big number up front we call the base. That's the base number. The little number up in the top, the superscript, is called the exponent. And then the entire thing we call a power. Okay? So the way we would say this is 2 to the 5th power. Okay, so in our chart here, we would show 3 to the 1st power. And really what that means is that's just 3 times nothing. The next thing we would do is 3 to the 2nd power, or we could call that squared, 3 squared. But what does that mean? It really means we're taking 3 times 3. Now I know what you're thinking. Wouldn't that be 3 times 2? No, it means that we're going to repeat the base however many times it says as the exponent. So that means 3 would be repeated twice. Okay, the next thing is 3 to the 3rd power, or we would say 3 cubed, which just means 3 gets repeated times itself 3 times. So 3 times 3 times 3. And then you guessed it, the last one, 3 to the 4th power would be 3 times 3 times 3 times 3. Okay, so here's some vocabulary words for us to check out here. Okay, a power is a number expressed using exponents. The example I'd like you to write in is 5 to the 3rd power. Okay, and that's this entire thing. The base is the number used as a factor. So in our example of 5 to the 3rd power, 5 is the base. An exponent is how many times the base is used as the factor. So the example of that would be, in our 5 to the 3rd example, it would be the small little 3 up in the corner. That's the exponent. Okay, here's something really cool to think about, is numbers that are perfect squares. Okay, so we said before that when it has an exponent of 2, that we would say it's called squared. We would say this number is 3 squared. But something that's a perfect square is a number that are square of whole numbers. So some examples here of perfect squares are the following. 1 is a perfect square because if I look at what 1 squared is, that would be 1 times 1, which gives me 1. Another example is 4. 4 is a perfect square because that would be 2 squared. 2 squared is 2 times 2. It's not 2 times the exponent 2. It means the base is repeated twice. A lot of kids get that one mixed up, so just be careful. 9 is a perfect square because 3 times 3 is 9. 16 again is a perfect square And you guessed it, that's because that's what 4 squared is, 4 times 4. And the last one I want to show you is 25. And yep, I bet you guessed it again. That's the same as 5 squared, which is 5 times 5. So those numbers are perfect squares, which is pretty neat. It's also really good to know that later in life. And our last vocabulary word I want to talk to you about is equivalent expressions. Equivalent expressions are exactly what you think, expressions with the same value. So the example I want to show you here is this. 4 squared is equivalent to 2 to the 4th. Well, why is that? Well, because 4 squared represents 4 times 4, which we know is 16. And we know that 2 to the 4th is 2 times 2 times 2 times 2. It's 2 repeated 4 times, not 2 times 4. 2 repeated 4 times. So I would take 2 times 2 to get 4, 4 times 2 to get 8, and 8 times 2 to get 16, which is the same as 4 times 4. So it's pretty cool. So the next thing I want to show you is generating an equivalent expression using exponents. I do not want you to solve these. I just want you to rewrite them. It's pretty easy, actually. I see the number 6. That's going to be my base. My exponent is going to be however many times it shows up. So in this case, it's 1, 2, 3, 4 times. So that would be 6 to the 4th power. In number 2, I see my base is 4, and I see it repeated 1, 2, 3 times. So that would be 4 to the 3rd power. Why don't you push pause on the video and try 3, 4, 5, 6, 7, and 8 on your own. All right, good job. Take a look at 3, 4, 5, 6, and 7. Did you get what I got? On number 5, you can just put the fraction in parentheses and put the exponent above it. And the same with number 7. I wanted to save number 8 for us to do together because I noticed something a little funky. I've got some 5s and I've got some 3s. So we could just set up 2 different multiplication problems, but we will set up our exponents with the 5s and the 3s only. So the 5s would be 5 to the 4th, and the 3s over here, that's just going to be 3 to the 3rd, because there's 3 repeated 3s there. All right, guys, in this next section, it's pretty cool. We're going to express each power as a product of the same factor. Then we're going to determine how much the value is. So I'll do this first one with you. It's pretty easy. We can say the 5 squared is the same as 5 times 5. And we all know what that is. That's 25. So take a moment and try 2, 3, 4, 5, and 6 on your own. They're a little more complicated, but I know you can do it. And let's see if we can get the correct answers in here. You're going to want to push pause on the video and ready, set, math. All right, how'd you do? Did you set up the problems like Mr. C did? I hope so. That was the easy part. The tricky part was kind of figuring out these tricky multiplications of decimals. You have to set it up. You'd have to do like 2 separate decimal multiplication problems. Okay, at least for number 2 there. Number 3, we just multiply across our numerators and denominators. We get 1/8. This one we have to do 10 times 10 times 10 times 10 times 10, which gives us 100,000. Wow. Number 5, we do 2 1/10 times 2 1/10 to get 4 41/100ths. And the last one we do 1/4 times 1/4, and that works just like we did number 3 across the numerator and denominator. All right, guys, we're almost done. let's take a look at these word problems. So what I'm going to do here is I'm going to see the zoo in the aquarium holds around 7 to the 4th power gallons of water. About how many gallons of water does the aquarium hold? So what I've got to do is I've got to do 7 times 7 times 7 times 7. And when I do that, I'm just going to combine these because I can do them in any order. So I know 7 times 7 is 49. And then, oh my goodness, I'm going to have to do 49 times 49. Woof. 49 times 49 gives us 2,401. Yikes. That's a lot of water. It also told us to do this, about how many gallons. So we're going to have to round. We just have to use our best judgment to round. I would say this number, 2,401, I would just say that that's the same as 2,400. When you have that many gallons of water, 1 gallon is not going to make a huge difference. Okay, so that would be the rounding way for about. Okay. Number 2, a kilobyte is equal to 10 to the 3rd bytes. A megabyte is equal to 10 to the 6th bytes. How many more bytes of information are in a megabyte than a kilobyte? Well, here's some computer stuff for you. Alrighty, so we need to do our megabytes minus our kilobytes. So I've got to do 10 to the 6th, essentially, minus 10 to the 3rd. And I know what you guys are thinking. Can we just subtract the exponents? The answer is absolutely not. No, no, no. We've got to convert these to see what they're supposed to be. That's 10 to the 6th. 10 to the 6th is the same as saying 10 times 10 times 10 times 10 times 10 times 10. And 10 to the 3rd is just 10 times 10 times 10. Well, 10 to the 3rd is equal to 1,000. Okay, because 10 times 10 is 100, times another 10 would be 1,000. This 10 to the 6, guys, that's going to represent 1 million. Holy moly. Right? Before I get super cray-cray here, I do want to grab this 1,000. I want to try to line up my place values before I start subtracting here, because that's what a good math teacher would do, is line up the place values. So that's what we're going to do too. So when we subtract these two numbers, we'll end up getting 999,000. Because we're going to have to borrow quite a bit from the millions place all the way back over to the thousands place. When we do that, we'll just essentially be crossing out a whole bunch of tens and making some nines up there. You guys know how to do that. Okay, so that's 999,000 more bytes. Okay, another fish tank problem. Holding 2 to the 5 gallons. How many fluid ounces of water does the fish tank hold? Okay, so there's a two-stepper here. We're going from gallons to fluid ounces. Aha, tricky, tricky. You can't trick us. We're too smart. So we're going to do this. 2 times 2 times 2 times 2 times 2. That's 2 to the 5th. And 2 to the 5th is going to be, well, I can combine these. That's going to be 4. That's going to be 4 times 2. So it's going to turn into 16 times 2, which I know is 32. And that's gallons. The label is super important. That's why we always tell you, make sure you label, so that way you don't make any silly mistakes. So now we've got to convert this from gallons to fluid ounces. Well, what am I going to have to do? I'm going to have to set up a proportion, our good friend, the proportions. So what I'm going to do is I know that 1 gallon is 128 ounces. Okay, you're going to have to do some fancy star chart stuff to figure that out, but there are 128 ounces in 1 gallon. That would be a good thing to memorize, I think, just as we go on through life. And we know that we've got to match our gallons over here. And I want to find my question mark ounces. Well, friendos, we've got some math ahead of us. 1 times 32 for that scale factor will get us to 32. So you figured it out. We're going to take 128 ounces times 32 to make our equivalent fraction. So 128 times 32, friends, that's going to give us quite a bit here. All right, so when I take 128 times 32, that's going to leave me with 4,096. That was a terrible zero. Sorry, guys. Fluid ounces. Yikes. All right, last thing. Faith is turning 12 this year. She asked her parents to give her $1 on her birthday and to double that amount for her next birthday. If she continues this pattern, how much money will Faith get on her 20th birthday? So here's what we got to look at. Her 12th birthday, she's getting 2 to the 0, which is 1. Anything to the 0 power is 1. And we'll talk about that again later this week. So her 13th birthday, it'll double. 2 to the 1st, which would be $2. 14th birthday, it'll double. $4. 15th birthday, that's 2 times 2 times 2. That'll double the last thing, which is $8. We want to see how much money she's going to get on her 20th birthday. So to me, what's going to happen here is we just got to skip ahead to 20, the 20th birthday. So that's really going to be 2 to the 8th power. Well, we can solve that. We know how to do that. 2 times 2 times 2 times 2. It's 4 of them. 2, 2, 2, 2. Let's count and make sure that we got the right amount of 2's. 1, 2, 3, 4, 5, 6, 7, 8. Oh boy, we're ready for this. 2 to the 8th. Let's go. Let her rip. Just combining here. I can combine these 4's. 4 times 4 is 16. Do another 16. Then we've got to do 16 times 16. 16 times 16 is $256. Wow, that's a lot of money for that 20th birthday. You'll spend that all over at Taco Bell. They'll treat you like a king. All right, friends, let's head over to the partner practice. You can do this on your own, and then we will go over the answers in just a second. There's a whole bunch of problems here. I want you to try them all, and then I'll go through the answers for you. Whatever you don't finish is, of course, your homework, but you're probably watching this video along as you're doing the lesson anyways, so go ahead and try to get these done, and then we'll go over the answers in just a second. You might want to push pause on the video. All right, let's check it out. Check your answers. How'd you do? I love this here at the bottom. 2 to the 0 power, that's 1. 4 to the 0 power, that's 1 as well. Okay? The exponents are decreasing. ones at the bottom are the trickiest. I love number 12, though. That one's super fun. All right, guys. I hope that this lesson was helpful for you to see it in video format or to watch it over again. Best of luck to you, and I will see you around. Peace.